This is for Year 12 methods. It comes out of 6C trigonometry, and it's given that sine of x is equal to this, and we're in the second quadrant, find cos and tan. I'm going to show you two methods. The first method uses the identity, and we have two identities. The two identities we have are the sine squared of x plus the cos squared of x equals 1. And the second identity we have is that the tan of x equals the sine of x on the cos of x. Now this one here I know is in the second quadrant because it's from pi on 2 to pi. So x is somewhere in the second quadrant. And the sine will be positive, but the cos will be negative and the tan will be negative. And the identities work like this. That if sine of x is 5 on 13, then the sine squared will be 5 squared on 13 squared plus the cos squared of x equals 1. Cos squared of x equals 1 minus 25 on top of 169, which is 144 on top of 169, which means the cos of x is the square root of 144, which is 12, over the square root of 169, which is 13, and cos is negative, so the answer is negative. And that the tan of x is equal to the sine of x on the cos of x, and the sine of x I know is 5 on 13, and the cos is minus 12 on 13. That gives me an answer of negative 5 on 12. So that's using these two identities and the knowledge that we're in the second quadrant. The second method I'd like you to show you is a graphical method. I know I'm in the second quadrant. X is measured away from the x-axis in the second quadrant. I know that the sine of x is 5 on 13, so that's 5 and that's 13 because sine is opposite over hypotenuse. Now using Pythagoras' theorem, then if I call this a squared plus 5 squared equals 13 squared, a squared equals 169 minus 125, a squared equals 144, a equals 12. So that's 12, but it's in the negative direction, so it's negative 12. So here is x. I know that the cos of x will be adjacent over hypotenuse, negative 12 on 13, and that the tan of x will be opposite over adjacent, which will be 5 on negative 12, which is minus 5 on 12. Same answers. This is using the identities. This is using a pictorial method. However, because we're using Pythagoras' theorem, and this comes from Pythagoras' theorem, in actual fact, the theory and the mathematics is identically the same. We're just getting it in different ways.